Hello and welcome back. In this video, we are going to be continuing with the monitor thread. So Lee, why don't you go ahead and tell us what we're going to be doing now?
All right, we're going to start off with implementing the code for this. So we'll start from there and we'll see how far we go. Now, there's a couple more methods that I want to create, and I didn't create these in the initial skeleton because they wouldn't have made sense until we started filling this out. I really didn't want to just put them in yet, or at that point. I want to start putting them in now. So we're going to create a private void wait for available threads. Inside of here, we're going to do a check. We're going to say if get available threads equals 0, meaning we have no available threads. We're going to do a check to see if queue count is greater than 0. If that's the case, then we'll do a console.writeLine. Now these console.writelines, they're just for demonstration purposes and for helping out at this point in time. We'll convert them to debug.logs when we get over to Unity in an upcoming set of videos. I just want to put these in here now so that it helps you guys understand where the system is as things are being processed. So this one's going to basically say waiting for more threads to free up. So if we're at this point, wow. Yeah, yes, I would like everything in quotes. Or you could just delete the quotes because I didn't really want them. I have a love-hate relationship with ReSharper.
Yeah, I understand.
All right. And it's never used. Yeah, I know it's not used. Get over it. All right. Now, if we've gotten to this point, we've got 0 available threads. I don't want to continue to loop through the rest of the code. I want to pause this thread at this point in time until we have available threads. The way we're going to do this is rely on our wait handles. So if you look at our wait handle method, we have a wait any. Now what this will do is it'll cause this thread to stop at this point of execution until any one of these wait handles signals that it's done. Handles. So this is that's the little guy sitting on our highway with the toll gate. And he's got it lowered. And the moment we have an available thread, he's going to lift that gate, and then we'll be able to continue on and allocate that available thread to the next thread in our priority queue. So we can take this, come up here, paste it down here. And yeah, it might help if I call that a static. There we go. Public static. Now it's happy. All right, so that achieves the first bit of functionality that we need. So I can go ahead and close that one up. The next one is going to be cleaning up after our worker threads. So this will be another private static void so we'll just call this one cleanup. Now let's call it worker thread cleanup. A little bit more descriptive. All right, so our worker thread cleanup is going to loop through all of our worker threads. We need to find out which worker threads are still alive, which ones aren't, and the ones that aren't need to be cleaned up. So we'll do a for I is going to be, we're going to do, here, let's use resharper because this is a reverse iteration. All right. We're going to use a reverse iterating for loop because we're going to be operating on a list. If you iterate from 0 to the end of the list and you start removing items inside of a list through the enumeration, you're going to get an error. So the way we avoid the error is by starting at the end of the list and counting back to the front of the list. So it's perfectly fine to remove the last element on a list or an element that you've already iterated through and then continue forward to the front of the list, and that won't cause an error. So that's why we're going to use the reverse iteration for loop. So we're going to start I at workerThread.count. WorkerThreads.count -1. And as long as I is greater than 0, we're going to continue to iterate through. And let's get rid of these. And if our worker thread is not alive, so worker threads element I is alive. So if we're not alive, then we know we need to clean up after it. So we're going to go ahead and say worker thread threads sub I dot stop. And if you remember when we were implementing our worker thread, we have this virtual overridable method called stop, and that's where we said that you would put all of the functionality if you needed to do any cleanup work. I believe inside of our test worker thread we had put in some cleanup code. So we need to make sure that this cleanup code is called, and that is accomplished by calling the worker thread stop once it's no longer alive. After we've done that, we're going to do worker threads dot remove, and we're going to remove this worker thread. So that's going to be worker threads sub I. This will remove it from the list, which is how we're going to be able to know that we have more available threads, because once we remove a worker thread from the worker threads list, our available thread count goes up. So it will no longer equal 0, which means then we can allocate more worker threads to our thread pool. So we'll take this and we'll put this up here. So that handles the second part of the functionality.
All right. So is that everything you wanted to do in this video?
Well, it's going quite well, and the remaining functionality isn't but another 4 lines of code.
Okay.
Or, well, of real code, so it's nothing much. This is going to be allocating our worker thread, so we can probably just knock that out real quick. Otherwise, the next video would only be a couple minutes.
All right. Well, let's go ahead and take care of it then.
So we'll do private static void, and this will be allocate new worker thread, or not new, next. So we're going to wrap this into a while loop. And we're going to say, well, get available threads is greater than 0. And the reason we're going to wrap this up in a while loop, it is completely possible that we have more than a single available thread. So we want to make sure that every available thread is going to be allocated. So we'll loop through as long as we have available threads. And we also to make sure that our queue count is greater than 0. There's no point in trying to allocate threads if we have no threads in our queue to be allocated.
Mm-hmm.
So those will be our conditions. We're going to say var worker thread is going to be equal to queue.dequeue. Now this one's a little bit interesting. If you remember, I said I didn't want to pretty much explain what was going on here yet.
Right.
We are passing in an anonymous method that returns an iWorker thread. So we're defining functionality and putting it into our queue that's going to return some sort of worker thread. What we're doing here or down here is we're taking that functionality, that anonymous method that we stored inside our queue, dequeuing it from the queue, and then executing it. So that's what the second set of what are these things called? I always get them wrong. These are parentheses.
Mm-hmm.
So the second set of parentheses is calling or executing this anonymous method. This anonymous method is going to return a iWorker thread, which we are setting as our worker thread here. From here, we can then take that worker thread, call its start, and then we need to pass something into it. Now, what we are going to pass into it right now is nothing, because when we defined our iWorker thread, we sent nothing into it. And I told you told you guys when we were working on these iWorker threads that we were going to have to come back and revisit this and our worker thread abstract and add more functionality to this once we started implementing the thread pool. This is the part that we're going to have to do that. We will do that in the next video. So for right now, I'm just going to leave this worker thread start.
Okay.
I will say what we need to pass in. We have to send it the wait thread or the wait handle, because remember, the thread has to be able to signal when it's done. The way it's going to signal is via this wait handle, and the only way it can signal the wait handle is if we give it the wait handle. So we'll do that in the next video.
Okay.
But for now, we can just say worker thread.start. That will do what it needs to do.
All right.
And then we'll say worker threads.add, and then we're going to add this worker thread, because we have to keep track of our actively running worker threads. And the way we keep track of them is by adding them to our worker threads list.
Mm-hmm.
So this gives us the functionality that we need here. Let's copy this, paste that here, and we can get rid of the comments now because we've got these really nice named methods that pretty much say exactly what those comments did.
Mm-hmm.
Go ahead and build it out, make sure there's no errors because I haven't done that in a while. That will complete all the functionality that we need inside of the MonitorThread's run method. It will be it for this video. The next video, we're going to go back. We're going to revisit that iWorker thread and the abstract worker thread class and get those set up to deal with our wait handles.
Okay. So that will wrap things up for this video. Thanks a lot.